Hey guys, welcome to the third part of this video. For this one, we're going to focus on pages 5 and 6 of the study guide. And they're not too long, so this shouldn't be too bad. We are finding limits, okay? And the hint here is remember the definition and the alternate definition of a limit or derivative and what it tells you about a function. So remember, we learned way a long time ago that the definition of derivative is where the limit as h approaches 0 of f of x plus h minus f of x all over h goes to 0. Okay, so that's the definition of derivative. We also have the alternate definition of derivative. So that's where x approaches a of f of a plus h minus f of a over a. Or no, x minus a. There we go. Okay. So basically what they're asking for is the derivative of that. And you can recognize it because it's f of x. And the derivative of natural log of x is 1 over x. And you're done. Okay. This one, slightly more complicated. The derivative of the function we're looking for is 2x minus 3 to the 1/3. Okay. And of course that's a chain rule problem. So the derivative is the derivative of the inside, which is 2, times, and then power rule the outside, 1/3. Leave the inside alone, subtract 1, so negative 2/3. And rewrite it as such. 2x minus 3 squared. Alright, this one is the one I was talking about with the alternate definition of derivative where they've already plugged in a here. So really what they're asking is f prime of pi over 2. So the derivative, or sorry, the function they want the derivative of is sine. And you know the derivative of sine is simply cosine. And then they want to know that at pi over 2, which is 0. Yeah, straight up. Same thing here, they want the derivative of cosine, which you know is negative sine. And they told you it's at pi over 4. So f prime of pi over 4 is negative root 2 over 2. There you go. Alright, number 4 is a good question because we haven't got too many like this. Okay, it wants the equation of the normal line when the derivative is 2. So basically, they're already telling you the derivative somewhere is 2. And that means the slope of the tangent line equals 2. So you already know the slope of the line you're dealing with right now. So slope of the normal line has to be perpendicular to that, so negative 1/2. So you can already eliminate ones that don't have a slope of negative 1/2, which is C and E. Okay. So now we just need to find our x and y values. So to find our x and y values, we need to figure out when the derivative is 2. So we're going to take the derivative. Y prime equals 2 e to the 2x. And we want it to be equal to 2. So we need to find x instead of plugging in for x. So divide by 2, e to the 2x is 1. Okay. E to the what is 1? 0. So x has to be 0. Okay. And then if you plug it back in, you get 0.0, 1. So that has to be a, right? Because y equals m. X minus x1 plus y1. Okay, we already knew that m was negative 1/2 from here. X we found was 0. Plug it into the original, you get 1. So that's just y equals negative 1/2 x plus 1, or answer choice A. All right, on to page number 6. Okay. Some more multiple choice that are pretty tricky. All right, we haven't done one like this, but this comes up a lot. So they want an equation of a tangent line, and then they want to approximate the value. So just like before, y equals m, x minus x1 plus y1. Okay, they give us the x value this time, which is nice. So y equals m x minus 1 plus y1. To figure out y1, I'm just going to plug 1 into the original function. So that's 1 squared times e to the 1, which is just going to be e. Okay, so this one's crazy. This will probably require the use of a calculator. Now slope, we have to figure it out at 1. So we got to take the derivative of this guy. So f prime of x is the product rule. So first times the derivative of the second plus the second times the derivative of the first. And that needs to be evaluated at 1. So that's e plus 2e, which is 3e. So y equals 3e times x minus 1 plus e. And we can distribute that if you want. So 3ex minus 3e plus e. So that's 3ex minus 2e. Okay, if you wanted it in slope-intercept form. And then they say approximate it at 1.1. On second thought, we're going to use this point. So we get 3e 1.1 minus 1 plus e. So they're approximating it at 1.1. So you take the tangent line and you just plug in 1.1. So it's y equals 3e times 0.1 plus e. And then at that point, this one actually has to be a calculator problem. Your test is not calculator active, but this one just happens to. So we would just do 3e, okay, times 0.1 plus another e. And I get 3.534. So answer choice A. All right, and we'll do a lot more of those as time goes on. All right, number 6, we've got definitely a chain rule. This is actually a double chain rule. So I'm going to start with rewriting it. All right, and you start with the innermost function. So the innermost function is this pi minus x, so the derivative of that is -1, right, negative x. Then the next function we have is cosine, so that's negative sine. Leave what's in there. And then the outermost function is this 5x squared. I think we've done this problem before. Okay, so there is your derivative. Clean it up just a teensy bit, so that'll be positive 10 sine pi minus x cosine pi minus x, and then we're going to plug in pi over 2. So that's sine of pi minus a half pi is just a half pi, and cosine of pi minus a half pi, which is a half pi again. Okay. The cool thing is cosine of pi over 2 is 0. So it all goes away. All right, this one's interesting. So it says, for what values of k does the graph of k times e to the 2x plus 3x have a normal line whose slope is -1/5 when x is 1? Basically what they're saying is, this is g prime of 1, okay, because that's what they give us, has to be 5, because it's normal, right? So it's opposite reciprocal. So I'm going to take the derivative, plug in 1, set it equal to 5. So g prime of x equals 2k e to the 2x, because of the 2 up here, plus 3. So that's the derivative, and I'm setting it equal to 5. And I'm going to plug in 1, 2k e to the 2 plus 3 equals 5, and solve for k. So subtract the 3, so I get 2k e squared equals 2, divide by 2, divide by 2, k e squared equals 1, divided by e squared. So k is equal to 1 over e squared, which is how I would leave it. You could also put it in your calculator if you were curious about the actual value. So 1 over e squared, which is 0.135. And that's the end of part 3. Catch me on the next part for the last couple problems.